Okay, concept number 4. This is kind of a long one as far as vocabulary goes. So there's quite a few vocab words we have to write down before we can really do some examples here. So first things first, measures of central tendency. It sounds really complicated, but really it's not. Measures of central tendency just give us a, what am I trying to think of? A sum of numbers that help us describe a set of data. That's really all it is. It's just numbers that help us figure out what a set of data looks like. And that consists of mean, median, and mode. And you may have heard of these before, hopefully. Mean, median, and mode. So mean is the sum of all the values in a set divided by the number of values, usually seen as x bar. We call this x bar. So if I talk about x bar, you'll know I'm talking about the mean. Okay, it's really important you know that these are the same thing. Okay, the median, when a set is ordered numerically, meaning from least to greatest, the middle value or the mean of the two middle values, so it's the very, very middle value, and the numbers have to be in order from least to greatest in order to find the median. Okay, the mode, the value or values that occur most often. A data set may have no mode, one mode, or several modes. So we're going to look at a few sets of data and we're going to figure out the mean, median, and mode. And then sometimes you may not have a mode. You will always have a mean and a median, but sometimes you won't have a mode, which is okay. So a weighted average, I'm going to abbreviate average, gives greater importance to some values in the set than others. And we won't really deal a lot with weighted average, but it's important to know what it is. Expected value. Like I said, there's a lot of vocab words. The weighted average of the possible outcomes for an experiment. So we're going to do a little bit with expected value towards the end of this lesson. Okay. A box and whisker plot. Hopefully you guys have seen a box and whisker plot before. You're going to be doing a project with box and whisker plots. So box and whisker plots show the spread of data set for 5 key points, the minimum and maximum values, the median, and the first and third quartiles, which I will tell you what these are, okay, how to figure these out. Okay, quartiles, like I told you I was going to tell him what they are the medians of the lower and upper halves of the data set. So really what you're going to do for a box and whisker plot is you're going to take the set of data and you're going to list it in order. You're going to cut it in half. So you have half over here and half over here, and then you're going to cut each of those halves in half. So this half of the half here is the first quartile, the half of the half up here is the third quartile. If that doesn't make sense yet, it will when we do it together. So the medians of the lower and upper halves of the data set, if there are an odd number of data values, do not include the median in either half. And we'll go through that. Okay? The interquartile range, or IQR, is the difference between the first and third quartiles, the middle 50% of the data. Okay? And that's really important in a box and whisker plot. A percentile, the value that divides the range of data set into two parts, so that the part below the percentile contains a given percent of the data set. We're going to deal a little bit with percentiles. Maybe when you have a little sibling that was born and people are talking about, oh, what percentile are they in? That has to deal with how many, what percent of babies are below height in that range, or, you know, I'm still not quite sure how babies are like classified in percentiles. But anyway, we're going to deal with percentiles. And then finally, outlier is a data value that is substantially different from the rest of the items in the data set. It's really easy to pick out an outlier. It's like, which one of these doesn't belong type thing. Okay, so that's all of the vocab in this video. In the next one, I'm going to talk about example number 1.